So today we will start with a more technical talk regarding frontend with David, which comes from Finium, and it's better for him to present than me.
Hello, everyone. First of all, thanks for having me. It's really great to be here. And great, it's working. That's a relief. So yeah, today I'll be talking a bit about dApp frontends. So basically, an introduction, not too technical, but also with some technical details about how you can build a front end for a decentralized application. So, a bit about myself first. I am David. I'm a front-end developer at Finium, and over the past few years, we've been building a lot of stuff in the Web3 space. We've had a lot of difficulties faced, but we've also learned a lot above all. So, hopefully, I can share some of that. Some of what we've learned along the way. Now, you might be thinking, why talk about this? Why talk about front ends for dApps? Well, naturally, as a front-end developer, it's something that interests me. But above all, there is so much going on right now. There's like a crazy rate of innovation, of new things coming up, that I think it's very helpful to have this kind of conversation when we're getting into the Web3 space. Because that's really one of the main problems, I believe, coming into this space, is trying to understand basically what is the overall architecture, you could say, how all the different pieces fit in, how we can make this work. And so to start with, this is a really broad overview, one possibility. So we have the front end on the client somewhere. Somewhere out there is the blockchain. We don't really know where, but it's there. We want to interact with it. We want to get data from it. So that is one connection there is. But it's quite likely that dApp will need a bit more than that. It might need a backend. It might need an indexing service to query data successfully. It might need storage, something like IPFS. And really, there are plenty other services I could mention. Basically, many specific needs, there are many services that you can use. But this is, we could say, a good starting point. So if we focus in on the front-end part, like how does it actually work on the front end? There are basically three key concepts, and that is the signer, the provider, and contracts. So the signer, you can think of the signer basically as the end user. In most cases, that is what happens. So there will need to be some user interaction so that you can have access to the signer. The user needs to basically approve the connection on their wallet. And the signer basically has the ability to sign mostly transactions, but also messages. And this is actually very useful, and we'll come back to this later. So we have the signer, then there is a provider. This is pretty self-explanatory. A provider provides data. It's our connection to the blockchain. You can think of this more as a read connection. And there are several ways of setting this up. We could use services like Infuda or Alchemy, these two, and I believe these are the main options currently. But if you're just starting out, you might not need to worry about this, because if your browser has the MetaMask extension, for instance, then that acts basically as a default provider. So just to get started, you might not need to actually sign up to these services. However, if you do, they're pretty easy to understand. So the final piece on the front end are the contracts, right? Because presumably your dApp needs to interact with stuff on the blockchain. And if there is a contract deployed on the blockchain, the front end needs to have basically a counterpart, an instance of that deployed contract, so that we know what functions it has, what we can do with it. So to create this instance, basically we need the signer and an ABI. So an ABI, you don't need to worry too much about what it is. It's basically a description of everything that the contract can do. This is an example, so we can do transfers, and for that we need to provide an address, another address for 2, and a value. So pretty simple, it's a description of the contract. All right, so now we have these 3 key concepts. How can we actually make things happen? Well, to begin with, I really recommend you check out one of these resources, so ethers.js or web3.js, and these are pretty standard general purpose libraries for interacting with Web3 things. So if you check out, this is Ethers, and if you're doing dApps, you will inevitably have to come back to this for reference. And yeah, so let's look at some code. And I'll begin with what is more like a basic, naive approach to this, but it's useful for understanding these concepts. Let's just see if this works. So, well, if you're making a dApp, one of the first steps is to choose like a bold color scheme and a monospace font. They usually work. Now, like I said, by having the MetaMask extension, what that does is it injects a provider into the browser. So I don't know if you can see this very well. Hang on. So if I do window.ethereum, there is a thing there that was basically placed there by the extension, and yeah, that's the read connection to the blockchain, basically. So I can go through this step, request a connection, and then we have, like, in this case, it's just a simple form. This is my address. I don't have internet right now, so it's not going to work very well. That's a slight problem. Basically, it displays my balance, or it would, if there were internet. That is also a requirement, an internet connection, by the way. So we have the balance and the basic form where I put an address, a value, and send. Okay, so simple stuff. So what does this look like? So this is how I'm doing the actual connection part. I'm getting that globally injected Ethereum thing, and I'm creating an instance of a provider with that. This provider class is imported from the Ethers package I mentioned. So then, once I have a provider, I can call methods on that. In this case, ETH request accounts. So this is like an RPC call that actually makes the prompt open and request for a connection. And there are plenty others. We can add chains, switch chains, but I'll just start with this one because it's the most necessary. So we need to await for the user to accept, and once they do, we get back an address. We can also have access now to the signer. So if you check this, signer.sign message, I can do this kind of stuff with the signer, like I mentioned. So I'm just saving this stuff. This is a React app, by the way, but it's just an example. So I save the provider, signer, etc. And I can also do something like this. So window Ethereum on some event, such as account changed, I would deal with that. This is like an event listener for when the user does things with the wallet. Okay, so this gives us a signer. This provides a connection. And I'm using that here. This is like the root of the app. So if there is a signer, I have the greeting and this component. So this component is the actual form where I have the inputs. And so if you go back here, what is going on here? First of all, there is a contract for this token, which is definitely USDC or something. I don't know. So I need to create an instance of a contract for that. And then I need to get the balance. And then I need to send. So that's basically first instantiate the contract and then interact with it. So how I'm doing that here is pretty simple. I have this function where I say new contract. I have the address of the token, where it's deployed basically, the ABI, which I copy pasted from somewhere, and the signer that I now have access to. So once I have that, I can just do things like contract, transfer, contract, balance of, pretty simple stuff. All these, of course, are async operations. So back in my component, I say get balance, so balance of the address, and now you're thinking maybe that will return a number, because that makes sense, but no, that's not what happens. This returns a big number. A big number is basically a representation of a number. It's complicated, but basically to transform that into a regular number, we have to use some utility function from ethers. And this is what I said, you'll keep having to refer back to the documentation for this kind of situation. So, okay, that's nice, that gives us a balance. How do we actually send stuff? That happens in this function. So it's pretty similar. Contract transfer, I pass in one parameter, which is where I'm sending it to, and then another value. So this parse units, before it was format units and now it's parse, is basically the opposite. So now I have a regular number and I want to transform it into a big number. So that's what's going on here. So this will execute the operation if the user approves, obviously. And I mean, that's it. That's all we need to happen, essentially. So wait. What is wait? Well, like I said, asynchronous operations. This transaction has a hash, but meanwhile it's being mined on the blockchain. So we can tell it to wait for a certain number of block confirmations, in this case 2. If I didn't define anything here, it would just do 1 confirmation, I believe. Okay, so that is like the basic approach. And it works, but you can probably guess that it has a bunch of problems. First off, there's a lot of boilerplate. There are a lot of edge cases that we're probably not considering. And we're actually only supporting one wallet so far, which is MetaMask. And it's very likely that if you have a dApp, you'll need to support a whole bunch of options. So, what can we do to improve the situation? Well, fortunately, there are a whole bunch of options out there that we can use to improve our lives and our dApps. One example is RainbowKit. Another is Web3 Modal. I think this was made specifically by the Wallet Connect team, in fact. And if you're looking for something a bit more complete that will help you deal with transactions, with actual interaction, you can use something like dAppKit or WagMe. Actually, RainbowKit depends on WagMe. It's like an extension that focuses specifically on handling wallets. But WagMe, okay, so a bit of context about WagMe. First of all, it's a terrible name, but it's actually a pretty good library. So I'll just show their documentation. I can't show the documentation. Basically, first off, they're backed by Paradigm. Paradigm are basically a company that backs several interesting Web3 projects. So it's a good kind of assurance that they are backed, so they will probably be around for a while, which is nice to know. Second, WagMe is specifically thought for React. It has pretty good integration with React, although it also has like a core version that you can use vanilla or use it to integrate with other libraries. That's helpful. Nice. So this is their documentation. They have this section for core, which is the vanilla section, basically, which is good. And then they have specifically a React section. They have a bunch of hooks here, which are very useful. And I'll go into a bit of detail about how you can use this to improve my previous example, essentially. Okay, so the dApp looks the same, except now we have a wallet connect button with this nice modal. We can connect. I was already connected. And we have the same form. Okay, so similar thing. So how can we actually do this with WAGMI? First of all, we have to create a base configuration which will sit basically at the root of your app, and it will wrap the whole thing, providing context for all the hooks you can use. That's what I've got here, config. So I have to pass in this client. And this is essentially how we want our Web3 part to behave. So first of all, we have this configure chains function. And what we're doing is passing in the chains that we want to support. In this case, mainnet and Goerli. A provider. And this, if you have, for instance, encoder keys or other API keys, this is where you would use them. And here we have polling intervals. So this is super useful. For those of you who don't know, polling is basically a method where you refetch data at a given interval. And that is very useful for keeping the UI up to date. So that is something that WAGMI does out of the box. So if you're like displaying someone's balance, it will periodically update. And it does that in a kind of for free way. So we're passing that stuff into this function that creates the client. And then we have this, so connectors. A connector is basically a method of connection in WAGMI. So we have injected connector, that is any connector that injects Ethereum into the browser. Not the currency, but the provider. For instance, MetaMask is an injected connector. And also Wallet Connect. Okay, so this is like the base settings. How do we do those interactions? So if we check out Connect, here we're using one of those WAGMI hooks called useConnect. And what this does, it returns several things, such as connectors. Connectors is an array of all those connectors we defined, so I'm looping over them and displaying a button for each one, like with the name. Unclick connect, and that will do the actual process. So you'll notice there are also these properties, like is loading, and I could have is error, is idle, is success. So this is basically the state of the operation, and this is very useful for this kind of async procedure where it goes through several states. What happens is that those states will update in the hook, and we can use that for conditional rendering. So instead of doing like sets loading and then doing the same for error and the same for data, we don't need to do that because it's taken care of by the hook, which is super useful, saves you a lot of time. So this does a connection, which is nice. If we check out the root, we can use this other hook, use account. That gives us an address and is connected. We could also do the same thing here, like is connecting, is disconnected, is reconnecting, all possible states. And then we have that same form here, details. Okay, so this is a little bit trickier, but still easy to use, I believe. So we have a couple of hooks here. We have use balance, which obviously gets a balance. We give it the address whose balance we want to know, which is mine in this case, the address of the token, and format units. So for those of you like who are aware, basically These tokens have a decimal setting, and it could be a number, or it could accept like ether, gwei, wei, etc. It doesn't really matter if you don't understand this right now. It will make sense later. So in our previous example, this is what gave us that crazy big number, which we had to parse in a very weird way. But what happens here is that we get balance, and I'm showing it down here, and it has like balance formatted, balance symbol. How nice. We could also get balance value, which is an actual big number. So the hook takes care of the actual parsing for us, so we don't have to like have specific utils for doing that. We just get formatted out of the box, which is very helpful also. So that was like the easier hook because it's just a read operation. How about sending, the actual write operation? That's a bit trickier. It involves two hooks. Use prepare contract write, which is a very long name, but it's accurate. And then use contract write. So this is basically an intermediary step, which returns us a config that we can use for the part that actually matters. So it's a similar thing. We pass in the address of the contract, an ABI. And by the way, this isn't the ABI I just copy-pasted. This is provided by WAGME, and it's strongly typed, which is helpful. By the way, I don't know the people who are in front-end here who deal with JavaScript if you use TypeScript, but I strongly recommend it. And this is one example where it comes in handy. So if I do function name, it's actually strongly typed to only use the functions that exist on this contract and which are write operations, so approve, transfer, and from. And then the arguments, so it's like to and the value. And these are also strongly typed, by the way. So if I do transfer from, it errors out here because it knows that the transfer from function needs 3 arguments and not 2. So just use TypeScript, yeah. Yeah, the arguments, I actually still have to use parse units. There's no getting away from it. You'll also notice this type, which is OX string. This is just weird. It's a string with OX in the beginning. It's not very useful. They decided to use it because it looks cool, I think. But it basically represents an address. So this hook will return a config that I can use in this write hook, and this gives me a function that I can call. I know this looks very kind of many steps to do something, and it's a very React way of doing something because it uses hooks, but it is actually quite effective here. So when I submit the form, it calls the write function, and that actually does the transaction. Again, here we get the state of the transaction, like is loading, is doing something, and we can use that here in the UI, so like is loading. Data, we access a hash on the data. So it makes it quite easy to add this data to the UI. Now, I know it looks maybe unnecessary to have this middle step, but there are actually some advantages to doing this way. Because when we do this kind of write operation, some computation is done, such as estimating gas fees, validating the arguments, and by doing this beforehand, we can save some time, make the modal, like the MetaMask modal, open faster, better as gas estimations. So there are some possible advantages to having this slightly more convoluted method. Okay, so I know that was many steps, but I hope you can agree with me that this makes things a lot easier, a lot more practical, and actually more reliable in the long term. So great. We now have a dApp. It's done. Not really. We have a front end that interacts with a contract, which is nice, and it works well. However, in most real-world cases, that's not going to be enough. We're going to need some access to data. Now, I'll give the example of NFTs. So you'll remember there was like that NFT craze some time ago, and it might come again, who knows. But that is actually a good example of the need for indexing. So you may know, not very relevant here, but an NFT contract will have any number of assets on it. And if we wanted to make a gallery with a nice front end where we display all those artworks with the option to buy or mint or whatever, we would have to get all the assets from the contract, right? So we could do something like contract get all the assets, or get all my assets, or something like that. But that doesn't work. It would be nice, but that's not how it works. Which is ironic, actually, because the blockchain is just a load of data, but it's not very accessible. We could get like the asset, a specific asset by ID. That would work. We could get a specific transaction. But when we actually need to build something useful for users with, say, historical data, aggregated data, actually useful data, then the blockchain is not very helpful. And we need something a bit more thought for front ends. So I'll see if this works. In my very good dApp, I have this gallery. It's a heavy request. It might take a while. Let's see, yeah. This is a bunch of NFTs. They're all very good, as you can see. And this is the kind of operation that dApps have to do. Get a bunch of data from the blockchain and display it. So how do we actually do that? Well, one solution would be to deal with this on your own backend. Like have a service on your backend that looks at the blockchain, records everything, provides it to the front end. That is one solution. But another option which we've worked with before is using something like the graph. This is an indexer. And let me show the graph. So you can check out their site. I'm not going to go into details about how you can set up the graph, because that would be a whole other talk and it wouldn't be me giving it. But essentially, it's an API for accessing blockchain data in a useful way. So there are some examples here, I believe. Yeah, explore. I don't know. Sushi swap. So it's a basic GraphQL interface here. And you'll see I have things like querying tokens, first 5, and I could do like order by ID or something. So you'll see this is kind of a regular, familiar looking API, and that's what the graph provides, essentially. It's an API for getting state from the blockchain. More specifically, what this does is, like, you create a service that is pointed at a given contract or more than one contract, and it listens to the events emitted by those contracts. It saves them, and it allows you to query them. That's like the very basic explanation of what it does. And that's what we can use on the front end. So I'm using specifically this GraphQL endpoint, and I'm doing this kind of query, like tokens that have a name, first 20, and just display them. And this is great because it keeps up to date. As the blockchain grows, this will also be kept up to date, and it's something that a front end can use. And it's not like bleeding edge, it's just an API, okay? It's something we know. Okay, so actually, speaking of NFTs, that brings us to another problem with dApps, which is storage. So, as you may know, storing things on the blockchain is kind of expensive, and storing images or videos is crazy. So it mostly doesn't happen. Instead, we have solutions such as IPFS, which is sort of the de facto standard for storing things in a distributed way in Web3 right now. Although, if you insist, you can use Arweave, which literally stores images and media on the blockchain. I've never used it, but it's worth checking out. So some of you may be familiar with IPFS. Essentially, it's a peer-to-peer network. What happens is that when you upload content to IPFS, it gets content addressed. So essentially, and a unique ID is calculated based on the content. And as you can see in this very good diagram, a hash is created based on a file, which is called a CID, and then you can use that to refer to the file. And this gives us some assurances. For instance, the same content uploaded at any point in the network will produce the same CID, because it's only the content that matters. Also, you can't have different content with the same CID, because it's unique to that piece of content. So it's not perfect, but it gives us some very important assurances that we can use in like decentralized applications. So how can you use this? Again, there are a bunch of solutions. One of them is NFT storage, like bold color scheme, as I said. This is a project actually created by IPFS. It really facilitates specifically storing for NFTs. They actually have like a very easy to use UI, which you could use if you wanted to manually upload things. Although if you're building a dApp, you probably want to interact with this through an API, which exists, obviously. They have this SDK that you can use, API keys, and that way you can upload stuff in a pretty easy way, and they will give you back the CIDs. So all this talk of NFTs, it obviously, it's a cliche by now that NFTs are just images and so on. However, storage in IPFS is not only for images, okay? You can actually store entire websites on IPFS, basically any content, it can be stored there. And this is just an example. It's a shameless plug also, because it was developed by our team. So this is an actual NFT, a regular 721 thing. But actually, it's playable. So obviously not an image. It's actually a whole front end, basically. It's a Tetris game built statically and stored on IPFS, which is then pointed to by the NFT. So it's kind of a far-fetched example, but it actually demonstrates how storage in IPFS and decentralized things, well, there's still a lot to be explored here. It's also a good game. So you'll have noticed by now that I've been talking a lot about regular services with APIs, GraphQL, like API keys, and none of that is particularly like bleeding edge. They already existed before. It seems very familiar, and that is one of the things we faced building dApps, is that a lot of the things that we'll build, they're not anything completely new. We're reusing a lot of Web 2 technology, and that is simply a reality of building dApps. Not everything is on-chain. That simply is not feasible. So I think that's a good moment to mention this, sign in with Ethereum. And this is basically a method that makes the most of a user wallet. So I'm going to try and find an example here. Fileverse. So you may have noticed this kind of thing out in the wild. This is RainbowKit, by the way. So yeah, MetaMask. So I've got this message. Come on. Yeah. Signature request. So it's asking me to sign a message, which says a bunch of stuff. It has my address. It has a timestamp. It has a nonce. Whole bunch of stuff. I sign it. And yeah, I'm logged in, basically. I can disconnect. So what's going on here? It's a basic method of authentication, as you could tell. basically what happens is that frontend makes a request to the backend for a nonce, for security reasons, obviously. And then it presents a message to the user for them to sign that has a nonce, it has a timestamp, a bunch of other stuff. The user has to sign that message and send it back to the backend. The backend now has the address, message, and signature. So it can actually look at those three things and validate that it was actually that address which produced that signature, which means that it's not an impersonator. It's not someone randomly sending a request saying, this is the address that I have. No, it's actually that wallet signed the message, really. So if it passes that validation, great, we can authenticate the session. So it saves authentication cookies or uses JWT, something like that, which will authenticate the user, making them logged in. So really, it's just a method of authentication which doesn't rely on emails and passwords. It uses the fact that the wallet is an address and a password at the same time, which is really cool. And I believe an example of how we can actually integrate Web3 technology and more traditional Web2 concepts and ideas into the same package, which is really cool. It's obviously not perfect. There are still problems to be solved. Of course there are. But it's overall something we're really excited into looking at, and we see it growing a lot constantly, and we're looking forward to keep sharing that knowledge and building with it. So that will be it. For now, I don't know if anyone has any questions. Thank you. Sure. I don't know if you need a microphone. Or I don't know. I don't know.
Hello, thank you for the talk. It was very interesting. I was curious about the number you sent as a parameter to the wait function, the number of blocks you were waiting to be synced up.
Yeah.
Why 2? Is there a standard for it? And a follow-up would be if the WAGMI default was 1 also, because I saw that there was no parameter there.
I don't believe there's a default. In principle, more is better. So if you don't wait any confirmations, well, it was registered, but it might not get mined. So there's it's a bit of a gray area. However, if you wait for as many transactions as needed, the UI will be stuck for possibly a long time. So I don't believe there's a standard safe amount. WAGMI, I believe, doesn't have a default. You would have to do that manually also. They provide a way. I believe they provide a way for doing that, yes. But I'm not totally sure. That's a good question.
Thank you.
No more questions? Anyone?
Right. Thank you. I could just look into the documentation, but I think we have time for the question. Does WAGMI provide an out-of-the-shelf way of computing the gas fee for a contract in this case, for this dApp example, instead of relying just on the MetaMask, for instance?
I believe so. Well, at least they have they have a hook for that. They have a use gas fees hook. I'm not totally sure about how much you can configure it to estimate a certain need. So I'm not totally sure about that, but it has gas fee estimation.
Nice, thank you.